Welcome, I'm Mike. I'm a Googler, I'm a statistician, and I'm passionate about learning and sharing. Today, I'm a friend and I welcome you into my office. We are in a series of videos that are following a GitHub repository. This is a GitHub repository that is using Jupyter Notebooks to show end-to-end machine learning operations. Today, we're in what I'm calling the O2 series. Let me put the screen up of the repository and let's talk about it a little bit. In our repository, there's a number of notebooks. Today, we're in the O2 series. I like this chart for describing that. Let's zoom in a little bit, make it easier to see. This is, and please don't click stop when you hear this word. This is AutoML. We are in the option of we are picking code. We're going to go to our notebook. The previous video, O2A, followed the no code and it went through the console and point and click created a trained model using AutoML. Today, we're going to look at the one where we actually use Python to orchestrate the creation via AutoML's API. So we're going to go to our notebook. We are going to do the same steps. We're going to create a Vertex AI dataset. That is just a link to an asset that holds data. Ours is in BigQuery. It could be the file we have in our Google Cloud Storage, the CSV we saved. And then we are going to trigger the use of that data with AutoML with a number of options. At the end, we'll take that model, we will deploy it to an endpoint, we'll get predictions from it, we'll even ask for explanations, and we'll talk about what explanations are. That's a fun bonus part of this video series. And then we'll discuss, when would we use this in practice? Like, why would this be helpful? So thank you for joining me on this video journey today. Let's jump right in and let's take a look at what we're gonna do. Full screen here. We know we started in our GitHub-based environment. If you have followed the videos and you've got your environment set up, you can follow along in that. If you haven't and you don't want to run them, you can just click the notebook in GitHub. O2B is where we're at today, and you can follow along directly from there. It has a full view of everything we're going to see. Now, what we know is over in the console, under Workbench, we created a Jupyter Lab environment. We've opened that, and we have it here. And we're going to open the O2B notebook and follow along. Now, this video that is shown at the top, that's the very one that you are watching right now. I call it end-to-end with interactive code. We have Python, we're orchestrating actions, we're waiting on them to finish, and then doing next actions. The next video is going to stay in Python, but it's going to bottle up a series of actions with a pipeline. Makes things very, a number of actions just put together that work independently and can be orchestrated and triggered. Stay tuned for that video next. As we come into here, we look at services. We are in a notebook. We are going to trigger dataset creation, which is a soft link over to live data, in our case, BigQuery. That is going to trigger the AutoML tables. We'll talk about the different model types in a moment. Once it's done building a model, it'll get deployed to an endpoint for predictions, online and batch, and we will even request from that explainable AI explanations from the final model. Today we are starting in notebooks. Here we are, and this is like Inception. This is the notebook inside the notebook, the picture of it. That is going to trigger walking down the tree of different services in Vertex AI. B, C, D, E, and F here. All right, so within Python, the only real change I need to make to this code today is our project name for the live videos is Demo3. We're going to keep our region. We know our data name is fraud. We know our notebook here is O2B. It's going to name assets as we go. I'm going to have to tell it compute resources to use when I deploy an endpoint. So I've plugged that in here using an N1 standard 4. That's a small one. It won't cost you very much. I've made a couple of variables to keep track of some things we're going to use. One is I'm naming the target variable for my model. We have that fraud data set from video 01. Each row is a transaction. Columns are it's principal component analysis of some other data sets. We don't know what they really are. It's a redimensionalization of a data set with all the descriptive info. So they're labeled V1 to V28. And then we have a column called class. Class has a value 1, it is fraud, or 0, it's not fraud. I wanted to label that variable here, class, and when I build a model, I'm going to emit some columns. One of those columns is transaction ID. This would be not very helpful for training a model because it's unique to a row. If it learns that a transaction ID is fraud, that's useless to future predictions because I will never see that transaction ID again. So it's unuseful for a model. We're going to load some packages. Basically, AI platform is the one that allows me to interact with Vertex. Date time package, so I can get a date time stamp from my assets. Google's BigQuery, so we can interact with that, and a few other things for data type we'll talk about later down. All right, AI platform. I'm going to initialize it with 2 things so I don't have to type them every time I call it, and that is the project ID and the region, the location in the project. And I'm going to get a BigQuery client going. Oops, I forgot to actually run the first cell with the variables. Mistakes in real time make this more believable, right? Timestamp. I want to grab a timestamp just so I can add it as a label to names in case this notebook gets run multiple times. Well, down to the second, I'm going to trust that since I'm the only one running, I wouldn't run it twice in the same second. I'm going to create a variable called dir. This is going to create a local folder in my notebook to store assets before I move them to Google Cloud. So here we see temp, and inside of temp, a folder for this notebook, O2B. Creating a data set. Now, I just finished the O2A series where we did this point and click in the console. If I go over to the console and click data sets, I see the one made there by clicking create. Well, with the API from Python, we're going to create a data set from that client AI platform. It's a tabular data set. We're feeding it a table. It has rows and columns, that fraud data. And we're going to create that from these pieces. One is we're going to give it a name. In our case, it's the notebook O2B. It's the data name, fraud, and it's the timestamp that I just created. We're going to tell it where the source is at. It's a BigQuery source, so we're going to use the variable bq_source, and we have to tell it the path in BigQuery to that table. Now, we created that in the O1 video. It's bq://. Project ID is statmicdemo3. Data name is fraud, and then we get fraud_prepped. It has the transaction ID in that splits column we created. Let's run that. Now, if we come back over to the console and we hit refresh, we see we just created that asset, that data set. If we click into it, we'll even see, hey, there's all the columns. It detected those. We could click generate stats and get some helpful info. It tells me the path to BigQuery. I could click that. It would take me to BigQuery and let me review it there, even run SQL against it. In our case, we know we directly want to go and train a model using AutoML. Now, I know I did this in the last video, but in case this is the only one of the O2 series videos that you watch, I'm going to recover it here. Let's pause and take a Q&A question right here. All right, that first question is going to be,
hi, Mike. What types of models can I train with AutoML?
All right, this is great. One, you stuck around, so AutoML didn't turn you off. I love AutoML because you feed it data, you say train a model, and it does feature engineering. Like in our case, we're giving it tabular data, and it's going to do things like scale data. It's going to subtract means and divide by standard deviations. It's going to see class variables, and it's going to one-hot encode them. It's going to kind of pivot them and say for every class gets its own column, and it's 1 or 0, is it or is it not that column, that class. It's going to see timestamps. It's going to extract like the date part, the time part. It's going to extract helpful information from text. Even if you provide text, it'll do good parts there. It'll build multiple types of models, whether it be a neural net or a linear model. It'll look at ensembles. It'll drop bad approaches and keep pursuing good approaches. It'll evaluate them. It'll even decide early, and we'll talk about what early means in a moment, that it can give up because it's found the best it's going to find. It can optimize more. But what is the one metric you feed it? And that is time. You tell it how many hours it can go for and keep trying. And after that amount of time, it'll take the best that it has and it'll give you that. There are some general recommendations in the guides on based on how many rows of data, if you're using tabular data, that you should give it. In our case, we have 250,000 rows. We're going to give it 1 hour. It's going to create a great model. We'll see that at the end. But let's do a screen share and talk a little bit more about the other types of AutoML models that are possible. I've got the link up to the manual here. You can use image data. You can bring in a group of images and you can build one of two types of models for this. Classification. You can analyze images and give those images labels, categories of what's in those images. Is a cat in this image? Is a dog in this image? Is a specific breed of cat in this image? There's both single class and multi-class. Do you see multiple things or one thing in this image? We can give it object detection, analyze an image, and return a list of things that you find in that image with boxes, XY coordinates that draw shapes around them. That can be very handy for different types of analysis. Our case, we have tabular data, rows and columns. This is supervised learning with AutoML, so there's a column that you're trying to predict. That column has one of two shapes. It's probably either going to be numeric, meaning it's like the size of something. It could be the weight of something. It could be the amount in an account balance. These are numeric responses in a range or that you're trying to predict. The other type is classification, meaning rather than this numeric range, it's kind of like this 2 categories or 3 categories or more, small, medium, large, fraud, not fraud in our case. That's what we're doing today. There's also the ability to do forecasting models. And that's a lot like regression in that you have rows and a column has this numeric response, but it has these groups of rows. And those groups of rows have kind of this natural sort order that's time. And it could be, daily measurements or monthly measurements, quarterly or annual. And that response that you're looking at, you're kind of looking at it over this swath of time and then saying, well, given how I've seen it behaving over the swath of time, how might it behave 1 unit into the future or 2 units into the future or 3? That would be a forecasting model. It can also take text data. It can take that blob of text and much like an image, instead of pixels, it's looking at tokens or words and it's saying, hey, this looks like a particular type of text. It looks like a novel. It looks like a tax form. You could do entity extraction where you inspect and you take out pieces of text and you start to label it like this is a movie review or this is a person's tax document they're about to file for their taxes this year. I don't know why I keep talking about taxes. The other might be sentiment. This is a very common application with text where you just want to know, is the person writing this happy, neutral, sad? You might even use that model to kind of route and make decisions. And then video, very much like images, but images in sequence. You could classify a frame or a segment or a video as maybe a sporting event or a school play or a vlog. You could do object tracking, like find a ball, a basketball, and watch it move around, or a hockey puck. You could look at action recognition, like things that are happening in a moment in the video, and categorize that. Today, we are going to stick with that model of classification, fraud, not fraud. Let's jump back to our code and say, well, what do we need here? Well, we know we have this data set that we've linked in a Vertex AI data set. We are going to tell the model columns to use as features. A very quick way to get that when you're in Python would be to hit the data set asset that we created up there, and it has an attribute column names. We could make a set Python that's a grouping of all the unique column names. And we could turn that into a list. but we could then remove and add to that list. We want to remove from that list the splits column. That's not going to help us train the model. We want to remove the target column. Like there's no, if you included the target in the model that you're predicting the target for, then it's perfectly informed and it's going to be a great model. It's not going to generalize or do anything well for any future data. So we remove that. And also any variables that we listed in the omit above, I believe all we listed was transaction ID. It's going to take those, don't be fooled by this split. That's just saying if I name multiple variables, split on spaces, and include all of them, it's going to take the transaction ID out of the list of column names because that's not needed for the model either. It would be very useless to include transaction ID because if it learned that a specific transaction ID was fraud, well, that transaction ID is never going to happen again, so it can't help us. We will then take that and create a dictionary from it. So let's run these two. If you're following along at home, you could take another cell there and just print that out and take a look at it if you wanted. We now want to define a job with Vertex AI, that AI platform client here. And to do that, we're going to say, hey, let's create a tabular classification job. That's my name. That is, hey, the client AI platform. An AutoML tabular training job is the type of job. We're going to give it a display name. O2B, the data name, and a timestamp. We need to give it a few other things. Now, some of these are optional, but I've included them on purpose. The one that's not optional is the type of model. Classification. We've talked about this is fraud, not fraud. Cool. Optimization objective is another point where we need to have a little chat. Let's do a Q&A on this one.
Hi, Mike. What optimization objective should I choose?
So back in the O1 video, when we first loaded this data and described it, we looked at the distribution of the target variable class, fraud 1, not fraud 0. And we saw that the majority of the data is not fraud like it would be in the real world, but a few rows, 400 and something out of 250,000 are fraud. That imbalance drives a decision here. We can't always use defaults when we use services. That's unfortunate, but fortunate. Let's talk about why we want to override the default here. If you're building a binary classification model, that's two classes, binary, classification, 1, 0 in our case, you would normally assume they're kind of balanced or they're roughly equal, half fraud, half not fraud. And it would pick a type of optimization as it learns that is based on what's called the area under a curve for a receiver operating curve. This is a particular curve where the y-axis represents true positives, meaning it was fraud and I identified it as fraud. And the x-axis is false positives. That means, hey, I labeled it as fraud, but it wasn't fraud. We obviously want that to be very low, and we want to label fraud correctly, true positives, very high. That would normally be a very fine way to optimize this type of objective. But we have a very big imbalance. Now, before we get to imbalance, if we have multiple classes, like 2 or 3 or 4, there's actually a generalization called log loss that would be the default. We don't want that one either. We want to take advantage of our knowledge that fraud is rare, rare-ish. And we want to pick an optimization that considers that. And another method is based on a different curve. It's the precision recall curve. What are precision and recall? They kind of say what they are. Precision is the y-axis of this curve, and it's the ability to precisely make a correct prediction for positive fraud. So it's the number of true positives divided by true positives plus false positives. So if you throw in false positives, it makes that number below 0. If false positive 0, it's 1. It's perfect. You want a model that has very good precision, but you also want a model that has very good recall. Recall is the ability to label, to predict the label is positive when it really is positive, and that one gets polluted in the denominator by false negatives, calling things not fraud that are fraud. You don't want to do that either. So we are going to pick that optimization method. Go back to screen share in a moment. There are two others. If you are in a field that one of these two is very important, you might even fix the value of precision or recall and optimize against the other one. That happened frequently. I came from the world of clinical trials where high stakes, like how much longer might a person live, or will they be cured, or how much likely are they to respond to drug A than drug B. You start to think more about fixing one at the cost of optimizing the other and seeing what you get. We don't need to do that today. Let's go back to our model, our screen share here, and we will see I've chosen to maximize the area under the PRC, precision recall curve. Maybe a whole other video on just describing that. We're going to talk more about that kind of stuff when we get to evaluating the model too. Column specs, that's that list of columns above that we want to include as features. And I'm going to give it a label so I can track the assets I create. It's just the notebook name. Let's run that. That creates a job type. Now we need to run that job. And this is going to create a model as its result. To run that job, you give it the data set. You give it the target column class. You give it, in our case, we've predefined a splits column that has our split of testing, training, and validating. If we didn't, these commented out rows, we could tell it to do like an 80-10-10. We kind of did an 80-10-10, but we have it fixed in our data, so everybody's using the same training data, for instance. We're going to give it a budget. In the console, we told it number of hours. Here we tell it number of milli node hours. Well, we're going to give that 1,000. 1,000 milli is 1, so that's going to be an hour. We're going to give it a display name, notebook name, O2B, with the timestamp and the data name, fraud. We're going to, and this is a double negative. Do you want to disable early stopping? Meaning, if you can't make the model better, should you go ahead and stop and return it? Well, yes. If you wanted to disable that, you would say true. So we say false, double negative. I know it's confusing. And then we're going to create a label for this as well, because it's going to create a model. We want that asset to also be called O2B. Hit run on that. And well, we gave it an hour, so it's going to run a little longer than an hour. If I come back over to here and I look at training jobs, I'll see that O2A, well, that's running from the console, that video. Now we have this job running. It just started, and it's been running about 9 seconds. It has a nice label. We can click it, and it'll eventually show us the training performance that it's getting there. It hasn't quite got going yet. Might even cheat a little bit on this video and look at what's happening in the O2A one. That one hasn't quite kicked in yet either. All right, so what we're gonna do is not make us sit here and watch this video for the hour or so that it runs. We're gonna go to the title screen, we're gonna pause the video and come back and review what happened. And we're back. We can take a look at the status of our job. Let's bring that up. We see that the Python code we submitted, this tabular classification job running, it continued to give us a status report of pipeline state running, and then it finished. If we go over to the training jobs in the console, we can see the 2B job here. It did finish, and it ran for 1 hour and 51 minutes. Now let's click into that. We get a little more information about the job. We'll get to the evaluation in a second. Let's go to the model properties. And what we see under model properties is that it had a budget of 1 node hour. We set 1,000 millinode hours, which is a 1 node hour. And that had a training time of 1 hour and 51 minutes. So we did say that it would be potentially more than we gave it, because there's some pre-tasks and some post-tasks that it has to do to package together what it's worked on. We get links to the data set that it referenced, etc. But that thing that we just clicked away from is the magical part, and that is an AutoML job and training here automatically has the information you want to use to do a high-level evaluation of this model. If we go back into code, that's not returned here. We could, potentially, score our test data with this model and then use our favorite, package in Python, maybe something from scikit-learn to create something like a set of statistics for evaluation. We would probably start with the confusion matrix, wanting to know true positives and false positives and true negatives and false negatives. And we would, draw a ROC curve, or in our case, precision recall curve. But in this case, the great part about AutoML is all that is actually done for us. Back over here in the console, we can immediately evaluate this model. And we see that at a high level, very high precision, very high recall. In the case of imbalanced data like this, fraud, very few cases were actually fraud. I don't necessarily trust high percentages because I could get 100% in a lot of ways just by labeling everything as not fraud, because very few cases are actually fraud. Let's first start with the confusion matrix. And one of the great things about this interface is, I just talked about percentages aren't my favorite. I actually like marginal information as well, like the totals. But I can click this little toggle and it switches to the actual numbers from the data. And what we see is the vast majority of the not fraud cases are labeled, predicted to be not fraud. Only 4 are predicted to be fraud. That's very, very good because you're only false alerting a tiny little percent of the time, 4 cases that you're saying, no, these are fraud when they're not. That's good. On the next line, items that are actually fraud, ones where you want to be alerted, hey, this is fraud, deal with this. 38 of the cases are labeled as fraud. That's great. It alerted us and it was correct and we intervened. But 15 of these were missed. I would call this a good model. I would say it's a great starting point. It doesn't make the bad mistake, putting my staff to work chasing down fraud that isn't fraud and alerting customers and alarming them and making them have a negative impression of our institution. That's good, but it's missing some of the fraud that is occurring. If I wanted right now with AutoML, I could say, since this meets that criteria, you could deploy this model, and while it's running, helping you prevent real fraud, you could then, behind the scenes, go to one of our later videos doing custom ML and make our job beating this. We would want to maintain this ability with the not fraud and increase our ability to detect fraud. Now, we also have great information up here. This confidence threshold is actually interactive. That's that for a class like predicting it is fraud, a 1, you have a cutoff where above this probability, you call it fraud. Below it, you don't commit to it being fraud. By default, for a binary, you'd probably pick 0.5. Anything that you believe more than half of the time is fraud, you call it fraud. If you slide this higher, what you're saying is, I'm going to make it really hard to call something fraud so that when I call it fraud, I know it's fraud. Like, confidence is very high. When you do that, what you're essentially doing is fixing the precision recall by a threshold very high, and you see that, well, yes, precision is 100%, and recall dropped to 0%. Your ability to recall the actual labeled fraud as fraud, it went away. That's the sacrifice with this. You want to go to that end. You probably also don't want to go to the other end, which has the opposite effect. Very low confidence, meaning, well, in this case, the model actually did okay, but you get a recall of 100%. Like, I thought it was fraud, or I knew it was fraud, and it found out that it was fraud. But precision, that's only 50%. What I love about this interface is the number of things I might have to do on a daily basis to just bring that data in and score it and run it through some algorithms to get charts. I might not have time for that every day. So that's a good use case for AutoML just making my job easy. It not only built me a model, but it gave me great information to evaluate that model right in front of me. The next thing that we're going to do is say, well, since we decided it's a good model, maybe not a great one, we want to put it in production so that it can be useful while we go to work making a better one. We're going to do that with code in this one. We did it with the console, just pointing and clicking back in the O2A video. We're in B. Next thing we need to do is create an endpoint. So that's that web address that's hosting the ability for us to send in a new transaction and get back a response that grades that transaction using our model. The way we're going to create an endpoint is give it a name and a label so I can find it. I like to always use the notebook as part of my naming because we have lots of notebooks in this series. When I do that, endpoints, they get created very quickly. I can actually go over here and click on endpoints. And I just created O2B with the timestamp. And there's O2B, and it's already ready. Now it shows 0 models on it. If you watch the O2A video or C, those are already in here. I've been running them all at the same time. If I scroll down next, I want to take that model I trained with AutoML, and I want to deploy it onto that endpoint. Now that kind of takes a snapshot of that current model and says, put it over here on the endpoint so that it can receive requests. When I do that, a couple of things I have to do. I have to name the model. So we've just built it up here and it's stored in the variable model. So I'm going to say, hey, make this endpoint and deploy the model into it. Give it a display name, a notebook, data name, fraud, and the timestamp. We're going to route traffic to it. Now it's the first model, so I'm going to send all the traffic to it. If I come up with a better model, what I can do is I can then deploy it with, say, 10% of the traffic, lower this initial model to 90%, watch it for a little while. So that means new request will 10% of the time go to the new model, 90% to the old. And then once I start to trust my new model, just make sure nothing's broken, I can fully replace the old model. So that's what traffic percentage is doing. We're going to send everything because this is our first model in the endpoint. And then we're going to tell it what type of machine or container to put behind this, amount of compute, and that we stored that in a variable up at the top. It was N1 standard 4 virtual cores. And we're going to tell it, hey, use one of those, and at most use one of those. This is an example where we're just working on it. It's not going into production. In production, you might choose a bigger instance to hold the constant amount of request for fraudulent transaction grading. And since sometimes that may go up, people have more transactions, say on a very busy shopping day, like the day after Thanksgiving in America, you could set the number of replicas to increase and it would be able to say, ooh, this machine's saturated, crank up another one. Ooh, that one's saturated, crank up another. And by doing that, you allow your response times to new transactions to stay very, very fast. And when you no longer need those computing resources, they can scale back down. The endpoints do this for us automatically with just 2 parameters. All right, so let's hit deployment. Now, this deployment of the model into the endpoint is going to take, I've seen it anywhere 6 to 12 minutes for this particular model when I'm running it. It's always going to depend on the size and complexity of the model and infrastructure that you're using, but it's still going to be fairly fast. So I'm going to go back to the title screen and pause this video, and we will come back after it is deployed. And we're back. Let's take a look at what's happened. All right, in our code, we see that the deployment of that model is now complete. This cell is done running. We can go over to the console, and under endpoints, we now see that O2B fraud with our timestamp has a model. This no longer says 0. We can click into this endpoint, and we'll see, hey, it deployed this model. It's ready to receive request. And it has data about the request it's receiving. Now, if you were looking at the O2A video where we deployed with point and click, from that AutoML model, it had a lot of information where we could even do a test right here. There's still the ability to hit things like sample request and get how to do a request, but I'm going to show you how to do this multiple ways right back in the notebook. So what do we have? We have a model that is pretty good at saying, given a transaction's information, I can tell you if it's fraudulent or not fraudulent. Let's take a record of a transaction and send it to that endpoint and get a response back and see what it looks like. So we can do this from the notebook. In this section, prediction, well, first we need to get some data to send. So while we have the data we use to do the training, let's grab some of those records that were labeled as test records. So those are the ones that weren't involved in the training. So right here, we're going to basically create a data frame in pandas, go into BigQuery and running a query where we select everything from, our project, fraud, prepped, where splits equal test. We can even, if we want to make sure we're grading a fraudulent record, we can say and class equals 1. So this will only bring back fraudulent records from the test subset. And let's limit it to 10. Run that, and very quickly BigQuery will return that to our local notebook here. We can take a look at the first couple of records from that. And we see, hey, here's all the features. And there's the class column. Of course, they're all ones. We subsetted to those. We have amount and transaction and class. Now, we also have the splits column down here. Before we send this for a prediction, we want to clean this up a bit. One, we only want one row of this. So I'll take the first row. That's the index down there. The other is we can use, similar to earlier, we can trim off some of these columns. Now we want to trim off the splits column. That wasn't involved in training the model. The target variable, well, there's no reason to give it to the endpoint. Well, that's what we want back, is the predicted target. The omit variables, we included the transaction ID. There's no reason to send that. It wasn't part of the training of the model. So all this code is doing is taking this first row and trimming off some columns using variables that are holding their names and storing that in new observation. Now we're going to prepare that new observation to send. Now, what I learned is that the AutoML treated the time as a string. It was time since some date if we look at the Kaggle description. I'm going to turn that into a string. That's what the model's expecting. I learned that through trial and error, to be honest. Then I'm going to create two variables, instances and parameters. And let's just take a look. This is making a JSON formatted version of that new observation, and then an empty one for parameters. If I just insert a new cell here and I print out instances, that's probably the easiest way to show what's going on. This is what our endpoint wants, is a structured version of a transaction. And that structured, it's called a struct value, has fields, and the fields have amount with value, a numeric value of 0. Field time, value is a string value of 134928. Field v1, those weird columns we have, has a value of 1.20493, . So we provide this highly structured version of a record to the endpoint to get a prediction back. How do we get a prediction? We're going to do it 3 ways. The first is using the same Python client we use to set a data set and train a model and create an endpoint and deploy to the endpoint. We're going to give it, the endpoint, a prediction request, passing it instances and parameters. Those 2 things we just looked at. We will get a prediction back very quickly. And what we see is it has predicted classes. It knows that it's limited to 0 or 1, 0 not fraud, 1 fraud. And it scores the 0 a 0.09, and it scores the 1 a 0.9076. So it believes this is most likely fraud, not fraud. Well, we know that's correct. We passed it a fraudulent record, and it predicted that it was fraudulent. That's great. It even tells us what deployed model ID that it scored it with. In case there have been multiple models in the endpoint with a traffic split, this is great info to know which model gave the prediction. And we didn't ask for explanations, so we didn't get them. We'll talk in a second here about what explanations are. If we wanted, we could write a little Python to clean it up and say, hey, what is the maximum score, and find its index, which is 0, 1. And then of the classes, what is the 1 index is a 1, and it will tell us. So let's run that. Now we know the actual concrete prediction is class of 1. Now we could do the same thing using REST instead of the Python client. With REST, we need to package that set of information that the endpoint's expecting in a JSON file. This first piece of code here will do that. We can even go into our temp folder for we're in 2B. We can see that file. We see that it's just a highly structured, beautiful version of that information for a single transaction. And then we're going to go down to the command line from our notebook, and that's what the exclamation is doing, is saying, hey, go out to the command line and run this curl command. Give it some authorization. It'll run gcloud to get my local authorization. It'll pass the JSON file to the endpoint, and this is the address of it. There's a few parameters in here, like the endpoint name. We want a prediction request and what region. Those get passed in from Python. When we run it, we get this nice little blob back that says, hey, predictions. It gives the exact same two scores for the same two classes. It tells us the deployed model ID. It tells us the original model that got to that deployment ID. That's beautiful. And the display name of the model. Now, another way you could do this, if you're working inside the Google Cloud, many people use the gcloud commands. This is a command line interface from Google to interact with all things Google Cloud. There is a command from the command line interface for asking for predictions. And here we do that. We go down to the command line, say gcloud, endpoints, predict, give it the name of the endpoint, pass it that same JSON file we did with REST. And we get this nice, simple piece of info back, but we also get the link that tells us what endpoint it used. Same information, because of course, passing the same transaction will give us the same prediction. Now, the next thing you might have is, on a daily basis, you might just collect a bunch of new records. Sorry about that. And I'm going to refresh my page to fix that. You might collect all of your new transactions and score them once an hour, once a day, maybe once a week, and just try to identify them as fraud. Maybe that's the use case for the model that you've built. If you were doing that, I'm going to show you how to trigger that from code, similar to in the O2A video, we did it from the console by creating a job. So scrolling down here to where we were, batch job. A batch job is using that same client AI platform to get to Vertex AI. It asks for a batch job and it creates it. It gives it a name, tells it what model to use. It doesn't use the endpoint. It's going to use the model. We give it where the data is going to come from. We'll use our BigQuery table, our source table. Format, let's output it to BigQuery. And let's tell it what the source table is. It's StatMike Demo 3, fraud prepped. We'll just give it that same data we use for training the model. And as an output, let's put it back into the exact same BigQuery project. Let's ask it to generate explanations and label all our assets with our notebook name. If I hit run here, this is going to run for, I believe, a couple of hours to generate all those predictions. Minimal compute resources are being provided here. I'm not going to hit run. I'm going to refer you back to the O2A video where basically these things that we're getting from the online endpoint, individual predictions, it's just doing that for every record and storing it beautifully in BigQuery for us to review, or maybe even create a view that subsets to frauds and have some other process picking those up and acting on them. So scrolling past that, and where that would show up, just in case you are running it at home, you could come into batch predictions and you would see a batch prediction job here. And when it's done, you'd be able to click it and it would take you right over to BigQuery to the table it created. You'd be able to review those records. All right, now, why did we rush through that? To get to our bonus content, the final part here. The AutoML model at the endpoint is enabled for explanations. This is a good point to take a little pause and do a little Q&A and talk about what explanations are before we review them. All right.
Hi, Mike. What are explanations?
So in my background as a statistician, I was trained to evaluate model parameters using things like confidence intervals and p-values for their significance. And I might even have interaction between parameters. I worked in healthcare and clinical trials, and we would try to say, is one therapy better than another therapy? And that was drawing inference on parameters that were like the betas that multiplied the impact of a therapy in a model. With neural nets, especially, you get so many parameters that method would be exhaustive. It wouldn't be a lot of fun. So there are really creative and amazing ways of explaining models, or explaining predictions from these models. And that's what we're going to get here. So let's talk about what it does. First, it says, what would be a baseline prediction for this model? Well, we know all the features that are going into the model. We know our training data that built those parameters. We could take the middle value for every one of them and then create a prediction from that. Well, what's the middle value? Mean's not great because the mean's not necessarily in the middle. It can be highly skewed by extreme low values or high values. So it takes the median, the middle value of any numeric variable. And for any categorical variable, it's going to take the mode, which means if you drew a histogram of it, which bar is the highest, pick that one. And it says create a prediction for that and call it the baseline. Now, for your current transaction, when you create a prediction for it, it gets a different answer than the baseline. And what this does is it says each individual feature's contribution to that difference from the baseline. So it gives you an impact of each variable, each feature, to the current prediction that you're requesting. That's amazing because when you build a model, it's based on training data. And in the real world, when you do predictions, you might get completely different combinations of the features than you ever had in your training data. And you might want to know, I got this really weird prediction. What caused that? Which variables drove that? This will tell you that. You can also have the case where you need to explain to the person, hey, we're telling you this is fraud because primarily this variable. Now, each transaction, it might be a different variable or feature that's driving the grading of fraud. So the person who's in charge of, or the machine that's in charge of interpreting the fraud and making an action on it, might want to know, what type of fraud is this? And you get that explanation, and what we're going to see in the next little bit here is by knowing what it is, you can drive your behavior, your research in a different direction. So let's look at that. So when I do an explanation on the endpoint, instead of endpoint.predict, it's endpoint.explain. You give it the same inputs. You can still, from the response to the explanation, get the prediction. And that's here. It's the exact same value because we gave it the exact same transaction. The next is a little bit of Python that takes the explanation part of the response and kind of parses it into nice, pretty output and prints it for us. And we see that baseline output value of a 0.900 and our current value of 0.90766. And we go, well, those are different. What drove that difference? And that's what the next part's going to do. Now, I wrote a little Python that is going to extract each feature's attribution to the prediction into a little data frame. And then it's going to use matplotlib, a Python library, to plot a chart of this so we can see it. So let's run this blob. And what we see is this particular prediction was heavily driven by V14. Again, those are principal components of some bigger data set, so we don't exactly know what V14 is, but in the actual bank that wrote this model, they might have that data, and they could say, well, V14 is number of transactions in the last hour. And they could go research that, and it would give them an informative way of looking at this particular fraudulent record. I just realized I'm not sharing my screen, so let me flip over here. And this is that chart we've been talking about. We could also say, well, V12 was heavily influencing, and all of these made this particular prediction higher. And what we saw back from the baseline output, the middle values, compared to this transaction, is that this one is just a little bit higher. And these are all those drivers to that higher. Not much was contributing to trying to make it lower. Everything was trying to contribute it to being more fraudulent than the average one or average fraud value. All right, let's go back to Q&A, do one more, and we'll wrap this video up. What question do we have here?
Why and when should I use clients to create a model with AutoML?
All right, in the first video, we didn't use clients. We point and clicked our way through the console, and over there answered the question about why do it that way? Experimentation, like I might not have time to go into an environment and create assets and do this type of thing, but over there I could just very easily go take this data, do AutoML, let me review it. Well, the client's also a great way because like this chart I made at the end, I got to use my preferred way of looking at the data and my preferred way of extracting the data and preparing it. You might like a completely different package. You might not like the confusion matrix that's in the console and you're used to using one from scikit-learn and Python. Well, you could easily load the data, score it, and feed it directly into what you want. Depending on what model you're building, all the AutoML is doing is building, hey, I have inputs, here's a good model for it. You can still evaluate it using the tools you've always used. That's amazing. As far as deployment goes, this gave me an interface that allowed me to drive that deployment in the way I wanted to. Perhaps I'm dealt with multiple data sets, or I want to simultaneously try AutoML and another technique. Maybe I want to do AutoML for separate segments of a data set. Code gives me that flexibility to do that, and that's why I call it interactive code. This is a great way to do those approaches. I say a good balance of both is a great way, and having both in your toolbox. The whole purpose of this series is exposing to many different workflows. Well, here's the same outcome, the same process with two different workflows, and I hope you find some value in that. With that, we're going to wrap this video up. I want to say if you enjoyed this video, hit like. It rewards me. It tells me, hey, good job. It also lets other people be able to find it. If you want more videos like this, hit subscribe. That lets me know people are waiting. And if you want to know when I upload them, hit the bell. Same time, if you've enjoyed this video, if it's given you value, drop a comment. That helps anybody else. Whenever I see a video this long, I typically don't watch it until I look at the first few comments and make sure people engaged with it and liked it. And ultimately, the most important thing you can do is if this triggered an idea you had for a different workflow, or you noticed something I did that you might know an easier way to do, or maybe you saw something I did that was a little wrong and you want to correct me. A great way to do that is this GitHub repository. If you came to the video first, the GitHub repository is linked in the description. Go there, click issues, start a new issue, reference O2B, and let me know. And we'll interact and we'll update it so that all future viewers will be able to get that information immediately, much faster than I can make a new version of this video. With that, I want to say thank you for your time, your feedback. Let's work together to make the practice of AI and ML more collaborative, accurate, and approachable to a wider and more well-connected audience. Thank you, and have a great day.